Alright, so let's go ahead and take a look at our free fall problems here on page 3, I believe this is. Alright, so obviously all the answers are here to begin with, but I want to take a minute to explain what the heck's going on here. So we know that there's a couple of formulas that we can use. First one, we're talking about our distance in the y direction. I have just y here, but sometimes we'll see it listed as d sub y. That's another way of notating this. Same deal though. So our distance in the y direction equals our initial velocity in the y direction. Again, we're never going to put anything here for the initial, that little 0 looking symbol or our little mini y looking symbol there. Those are both simply to just tell us, okay, we've got that's the initial y, we're talking about the y-wards direction, if you will, the up and down direction. The only thing that will actually put anything in ever for, any number in for, is that v. Alright, so let's go ahead and take a look at the rest of our variables here. So t obviously stands for time. G is going to be gravity. In this case, we're using gravity to be negative 9.8 because that's what they tell us on the page here. So G would be negative 9.8, 9.8 meters per second squared. All right. So that's why this column right here can be filled out right away, because gravity is the thing that's acting on the ball here. Gravity is the thing that's actually pulling us in this downwards direction. So no matter what, it's going to be negative 9.8 meters per second squared at the first position, the next position, the position after that. Any one of these positions were being pulled down by gravity, so that's why we're at negative 9.8 meters per second squared. Alright, so how the heck do we figure out these other columns then? So this column, we're going to end up using the dy equals v naught t plus 1/2 gt squared for every single one of these distances. So if I don't know my distance, right, because I'm not going to know this if this weren't here, I need to know my initial velocity. Well, my initial velocity is 0 to begin with. So my v naught y is 0 meters per second here. My t would be 1. So let me actually go ahead and do this one off to the side here. dy equals v naught t plus 1/2 a t squared. Okay, so distance I don't know, right? That's what I'm looking for. V naught is 0, because again, I'm dropping to begin with. T, I actually should put a 1 there. Plus 1/2 a is negative 9.8 because it's gravity, and then t squared would be 1 squared. So what do I come out with? I come out with d equals 0, right? 0 times 1 plus negative 9.8 times 1 squared. Well, 1 squared is 1 times negative 9.8, still negative 9.8. Half of that is negative 4.9. 0 plus negative 4.9 gives me negative 4.9, but I'm talking about my distance from the beginning. So because this is distance, not displacement, I'm just 4.9 meters from the beginning, so that negative doesn't matter. Really what that negative tells us though is that we're going in the downwards direction. So that's all the work that I would end up doing for this first problem right there. The only thing that would change for the next part is taking out 1 for my time, sticking 2 in there. For the third one, it would just be a time of 3, fourth one for a time of 4, fifth one for a time of 5. Everything else would be the exact same though. Alright, so let's go ahead and do an example problem for my velocity then. So my velocity, I'm looking in the y-wards direction, or the up and down direction. And it may confuse to put these little subscripts next to it with this. It's easier, I think, personally, I think a lot of times just say v final minus v initial equals our acceleration times time, or it could be our gravity times time, since gravity is our acceleration. So our velocity final, we're not sure, right? That's what we're looking for. My velocity to begin with is, again, where I'm dropping from, so that's 0 equals my acceleration, negative 9.8, because again, that's coming from gravity pulling me down. And my time, in this case, is 1 if I'm doing this example problem here. So how do we get that? Well, v minus 0 is just v equals negative 9.8 times 1. That's simply negative 9.8 meters per second. And that's how I got that answer. If we wanted to do the next problem, we just take that 1 out, substitute a 2 in for my time, and I get that value. Following problem, I take the 3, substitute it in where that 1 is, and I'd come out with the next problem after that, and so on and so forth for the rest. So that's an example problem as to how to do all the rest of these. And again, we already talked about acceleration. Acceleration is going to be the same because gravity's pulling us down. Alright, so let's take a look at this next part here. They're talking about, or this problem is talking about the diagram that's on the side here. The diagram is of a ball thrown straight up, so this ball is being thrown that way, starting at point A, so this must be like maybe somebody standing on a platform or a cliff or something like that and throwing the ball up. And then it comes back down. So they're starting at point A, ending at point F here. The time between each point is 1 second. So from here to here is a second, from here to here is a second, from here to here is a second, and so on and so forth. All right. So if we wanted to figure out what's going on here, we can use some of the same formulas that we're using up top. Velocity at point A is 20 meters per second. So throwing the ball up at 20 meters per second. Stating the velocity at each point is fairly straightforward from there. So at A, that's where I'm actually throwing it up at 20 meters per second. Gravity's fighting me the whole time though. So at this point, gravity is already pulled down by 10 meters per second. So now I'm only got 10 meters per second of speed left. By the time I'm up at point C, I'm going to be at 0 meters per second. And because I've lost another 10 meters per second. Well, after point C, now at this point, I'm at 0. So after point C, now I'm being pulled in the downwards direction. I'm actually starting to have a velocity in the downwards direction as well. This would be negative 10 meters per second. The next one would be negative 20 meters per second because I'm being pulled down by another 10 meters per second. And after that, I'd be at negative 30 meters per second just before hitting the ground because, again, I'm being pulled down by yet another 10 meters per second. So that's how I got my values here. I'm on the way up. But I've lost some speed on the way up. Actually, at my maximum, I've lost all my speed. Now I'm on my way down because gravity's pulling me down still. A little bit further on, a little bit faster on my way down, faster yet on my way down. And again, this would be right before hitting the ground because obviously once we've hit the ground, then we're at 0 again after the bounce and everything. So what's the acceleration at each one of these points? Always negative 10 because that's what gravity's pulling me down by negative 10 meters per second squared. Really negative 9.8, but we round it off in this case. I don't necessarily like how the worksheets do that, where every so often we're using negative 10, other times we're using negative 9.8. If in doubt, use negative 9.8. You'll be right most of the time. All right, so let's take a look at how high point C is if F is on the ground. Well, in order to figure this out, we kind of have to work almost, I'd say almost backwards in a way. We're going to say that this point up here, point C, maybe I'll do another color for this. This point right here, point C, that is where my initial velocity is 0. And we know that we're getting to the ground in 3 seconds, right? 1 second here, another second here, and then a third second here. So that's where I'm getting this 3 from. And squared is part of the formula, right? My gravity is pulling me down at negative 10 meters per second squared. So that's where I'm getting this number from. 1/2 is part of the formula. Again, 3 seconds we got from the fact that I'm falling 1, 2, 3 seconds. My initial velocity is 0 up there. So after going through and doing all my math, 3 squared is 9 times negative 10 is negative 90. Half of that's 45. This is 0. Negative 45 plus 0, it leaves me at negative 45. Well, that means I've fallen 45 meters, right? That's what that negative represents. Well, if I fell 45 meters, that means I must have been 45 meters up there to begin with, right? So how high is point C? It's 45 meters above the ground. How high is point A? Well, point A is after we've fallen for 2 seconds, right? Is where point E is. Well, point A and point E are in the same plane. So how the heck would I figure out how high up I am at point A? Well, to begin with, I can say that my time falling for point E is 2 seconds, right? So that's where I'm getting this 2 from over here. Again, the negative 10 comes from gravity. We've rounded it off. The 1/2 is part of the formula. The time over here would still be considered 2 because it was over here. It was 2 over here. And my initial velocity at this point is 0. The reason that this point up here is so special, why do we keep referencing that, is because that's where we have a known velocity. For sure that's 0, because the ball had to have slowed down in order to fall back down to the ground. All right, so at point E, I would say, well, after 2 seconds, how much have I fell? Well, the ball fell for 20 meters, right? So if it fell for 20 meters, so let me go in this maybe pink here, purple. If I fell 20 meters, and I know that point C is 45 meters, well, that would mean that from point E to the ground leaves me over with 25 meters. And I know the question asks us for what about point A, and I keep referencing point E, but again, point A and E are in the same plane, so however high up point E is, point A is also. So point A is 25 meters above the ground.